Welcome to tonight's meeting of the Hand-Eye Supply Curiosity Club. We are your hosts this evening. I'm Tobias Berlinger, and this is Will Lacoma. Together we have a number of curious and exciting topics to share with you.
Our series highlights an eclectic group of speakers, experiences, and workshops across a broad range of subjects in the areas of culture, design, science, technology, art, fabrication techniques, and lost common knowledge.
As attendees of the Hand-Eye Supply Curiosity Club, you are now all members, provided you adhere to our philosophy.
Ex curiositas
scientia. We pledge to learn without prejudice in pursuit of our mutual goal, perpetual noviceship. We admit that it is impossible to know everything about anything, and thus we remain perpetually curious and perpetually novice.
This is our flag and our mascot, Franklin.
The lightning bolt represents the receipt of knowledge, the enlightenment of illumination, the resonance of truths understood. It awakens and excites us and makes us hungry for more.
Kurt Mottweiler and his small gray feather companion Zane are regular attendees of the Curiosity Club, and we are thrilled to have Kurt speaking to us this evening. Kurt meticulously designs and builds traditional film-based cameras that range from the simplest lensless wooden cameras to fully computer-controlled rotating panoramic cameras. And with that, this is Kurt Mottweiler.
First of all, I want to thank these two for doing this. As I say, I've been coming for a while, and it's just great fun. The collection of people I've had for speakers are just really inspiring. It's been really enjoyable to come, and I hope the ones of you who are new will continue to come. I've just been looking at some of the new speakers. They look pretty interesting. Pretty cool stuff. Anyway, basically what I'm going to be talking about is this camera stuff that I've been doing since about 1990, maybe prior to that a little bit, but most of it started about then. Kind of an experiment for me to put together something to talk to people about, because I generally don't do much of that. I've always relied on having the website or books or magazines or something, kind of spread the word. So this is kind of a collection of, across the front there is going to be mainly the lensless cameras or pinhole cameras, with one little exception here, a little model for a rotating panoramic camera, and a few other things that I'll show later. But the bulk of this is going to be about the visual presentation that I put together, because there's just too much stuff to lug around and show. So I'll get that started. As he mentioned, I'm normally here with my little gray assistant, an African gray parrot. But when I'm engaged in so much commotion as is entailed with getting all this set up, he gets a bit panicky. So I decided to leave him at home. Plus, he'll probably hang out with my wife and watch the Blazers game tonight. He's a big fan. So anyway, let's get this thing started, and we start out with a little homage to him there. So this little piece up here is something that I put up on the website a long time ago, just kind of introducing my feeling about it, because I am I do a lot of photography, but I'm sort of centered on the cameras as my main art form, and sometimes explaining that to people is a bit of a trick. So when I first started, it was cameras kind of like these that were source of inspiration. They'll be kind of like the one that I've got over here. So these are typical cameras that were used in the early days of photography, and then these are two examples of ones that I built early on that are sort of inspired by that early precedent. The one on the left being a stereoscopic camera, and the other one sort of modeled upon the early daguerreotype cameras, the sliding box. I'm actually missing the back part of that camera at this point, but most of it's there and kind of gives the idea of what that's all about. Then this is another example from that time period when building all of these large format cameras. This is a rotating back for a 4x5 camera. So it's set up so that with the camera sitting on your tripod, you can rotate it and have either a vertical or a landscape orientation for the image. So I did that for a little while, and then eventually kind of decided that I wanted to do something a little more unique. So this was the first example. Actually, I used to have it in the collection. I just didn't bring it this time. It was the very first one. I just kind of wandered into the shop one day and decided that I wanted to do something new, and this is kind of what popped out. So that was the first example. Like any initial concept, it had its issues, though the idea was pretty much there right from the get-go. But I had fun with it. I was kind of interested in having something with a little bit of a Rube Goldberg feel about it. So the little knobs on the side that side of the camera made it. I guess one way I think about it is there are a lot of older cameras that were clearly designed by engineers that were not thinking about what the user experience was going to be like. The person actually using the camera. For them, it was like, here's a way that makes sense to do this from my standpoint as the maker, with no real consideration for what it's like to actually use. And this is actually sort of intentionally going there. It's kind of funky and clunky to use, but that was sort of an aesthetic I was going after at the time. So early on, this is like one of the first ads that I ran for it. I think it might have been in Shutterbug, something like that. And there was a lot of interest. I actually got interest from a guy from a group that I subsequently joined called the International Association of Panoramic Cameras. I went to a couple of their meetings and got involved with them and kind of kept up with it. So here's an example of the shutter on that one. Here's the bird in the background, actually. Okay, and this is kind of where it went. This is like a production version of it. The camera we're talking about at that point is like this. So it's a medium format camera that shoots 120-degree angle field of view. Pinhole camera, 60mm focal length. Some examples of photographs from that camera. That one from the Empire State Building, the California coast. And the Albuquerque Balloon Festival. I used to live in Santa Fe and Taos, spent a lot of time there, which is a great event, a lot of fun. And then there at the Golden Gate Park in San Francisco. And I don't know where that was, but doesn't really matter. This is another camera I built back about that same time. It's the first time I got involved with using computers to control cameras. And in this case, actually, I was again kind of interested in a sort of perverse aesthetic, because I was building this camera that, for most visual intents and purposes, could be traced back to say 1850, but was going to be run by a computer. I had this sense that when I showed this to some people more currently, I'm informed was pretty much a steampunk kind of an idea. Simple brass knob on it with a number sequence and a few brass buttons to operate the user interface. But it's actually a very sophisticated computer drive system that runs it, and programmed in a language called Forth. If any of you are programmers and ever encountered that language, it's one that was used in the past for programming hardware. Initially, it was all used for radio telescope arrays, and then kind of got worked into other areas. But it's a really interesting and sort of programming language. I've got some sample of the code for that computer up here for any of you who might be interested in looking at what it looks like. It's pretty strange stuff, but it's actually kind of fun. And then an example of a photograph from that. That's from where I grew up in San Antonio, one of the missions in San Antonio. And then the California coast. Not long after that, one of those guys came after me. And there's a little detail on that same camera. Any of these cameras this is called a rotational panoramic camera. So the camera sits still, but the lens moves within the camera, and you'll see it in this sequence here, moving across. That's the actual exposure pass there. And you can see the other side, it will close the shutter, and then right there, it's returning back to home position. So then I got interested in kind of carrying on this line here, and one of the things that probably impacts me quite a bit in the way I look at how things are designed and built, and what I'm interested in building was my childhood with my father. I worked for Porsche. There was a distributor for the entire Southwest region called Porsche Car Southwest, and he worked with them and also raced and taught race driving in the SCCA circuit. So I spent a lot of time around race cars and Porsches in particular. In fact, one of these sat in our garage for a couple of weeks, and little did I know then how much they would be worth now. But anyway, this particular, the Porsche Spider is a really interesting design to me because it's still at sort of an early stage from a design standpoint. It's got a rudimentary, but still has a really, I think, a really interesting aesthetic. And I think that sort of informs what I'm doing here. it's sophisticated but not overly so. You know, it's not so integrated. A lot of cars you look at now, it's like everything about them is so fully integrated. And you know, if you look at something like this, it's more kind of back to the roots. It's sort of the bare bones basics, but still a beautiful object. So what came out initially from that design experiment to produce a subsequent camera, a follow-on to this one, and this one here, which I sort of cannibalized, I used parts in subsequent versions, is the one that you're looking at there. And that one came about pretty quickly. Like the first one, the design is very much centered around the notion it's a 120-degree field of view. And so you've got to find room for that, both in the film compartment and in the view the camera has out in front. And I'll show you in a moment a diagram that sort of shows how I work that out. But anyway, I built this camera and subsequently took it to Italy, took a bunch of photographs with it. But every time I saw it sitting on the tripod like that with the little wings sticking out, I was thinking, boy, if I whack that thing, that's going to be an expensive, difficult, if not impossible repair. So when I came back, I was like, you know, I like it except for that, and that's just not going to fly. And so this is another example of that same camera as I took it with me. So what I did is I came back and did this to it. Essentially, I pulled the hinge doors off, and I had so much time already invested in the basic layout of this camera that I had to come up with a way to use the same basic design. So I came up with this idea of making this back that sort of wraps around it. It turned out to work quite well. So that was one of the initial prototypes for that camera, and took that out and did some shooting with it, and I liked it and decided, well, that's probably the way to go. So that became, actually this initial shot here is of my own camera, the production version. It's a little different, but that became the final version of this. Speeding up a little time here, and then we get to these 4 shots show the front, the back, and then the film path it takes through the latch mechanism. The way that back latches onto the camera has the centerpiece there on the back of the camera is what it latches into, and so the film, in this case the paper leader on the film, has to go behind that and across the film rails over to the other side to the take-up reel. And then on the right there you can see how the back then fits back onto that. This camera was built, in fact, they all are, in this series are built entirely of veneers. So they're all either 3, 5, or 7 layers of cross-banded laminated veneers. It was kind of a self-inflicted, delusional experiment that made a very fine final product, but was incredibly difficult to do in practice. I've got, well, countless, I've got several hundred photographs of the process that I go through to build one of these things, which I don't actually build anymore. But needless to say, it's very involved and kind of ate my lunch. So anyway, here's the diagram that sort of shows what's involved in generating a shape like that. So the red there in the front and back of the camera sort of shows the field of view that I'm dealing with. So I've got 120 degrees out front, and so the front shape of the camera is sort of responding to that to make room for it. And then within the body of the camera, what you see is that same field of view plus room on either side for the film reels. And so it's pretty optimized for that field of view. And in fact, with even the first camera, particularly these cameras, the fitness at the shutter is really critical because you've got that 120-degree angle of view that you've got to maintain. So everything that goes into designing the shutter even has to be fairly closely controlled to not interfere with that final image. So this is a little bit of the production process involved with that camera. The one on the top left is a pre-bending fixture. I actually worked for a while in the lutherie world with my friend Bill Collings building guitars, so a lot of what I do is sort of informed by that, and anybody who's familiar with lutherie will recognize that fixture as being somewhat similar to a guitar side bending jig. Then on the right is a sort of a standard issue vacuum setup for once that. It's actually the pieces with lengthwise grain that are being bent on that fixture, the cross grain pieces will take that curve quite easily. But what I wanted to do is to have no embedded stress in it when I laminate it together. So once the lengthwise pieces are bent, they go in with cross laminated pieces interspersed between into the vacuum. And then the piece below, the shot below shows the beginning of the assembly process where I'm then attaching the, again, shop-made plywood tops and bottoms to that piece that was just made in the initial process. this is the clamping fixture that's actually used to do that, to glue the front to the bottom panel and then flip around and do the top panel. And there are, like I said, there's probably 75 to 100 different fixtures of one sort or another that are kind of like this that were involved in building this thing. This on the left at the top there shows a vacuum chuck that's used on the lathe to actually hold the camera body for what's being done on the right, which is to cut the recess at the shutter. And you can see that in this case sort of in the original form, where you can see the laminations of the wood kind of showing through as it gets cut through. And then bottom left is a process again on the lathe on the vacuum chuck that's grinding through those layers and cutting a nice even surface for the subsequent operation. What I found with this was it was very difficult to get that to work for a variety of reasons I won't go into, and I ended up doing, I believe you see it here, an insert, which you can see on this camera. So the picture on the bottom right is the blank insert actually glued in after that lathe operation. Then it goes back on the lathe and gets the hole cut back to the 120-degree angle, and then to this operation to clean it off and shape it to the front shape of the body of the camera. Then, looks like I snuck a repeat in here. Let's see if I did it all the way through. Yeah, here we go. So this is the Cathedral in Milan. Oh, we skipped a few. Okay. So on to the next one. This is the beginnings of my work on a rotating panoramic camera. And so in this case, we've kind of moved away from the wood construction. But here I'm going back to sort of inspiration. This particular little camera is one that I've long been a fan of. And my stepfather was a collector of cameras and had a series of those and ended up giving me one of those for a while. And then as he passed on, he gave it to me permanently. So it's been a real source of inspiration. It's one of my favorite cameras, of older cameras, and anybody who's sort of delved into the world of design would know Walter Dorwin Teague and his work. So this is the camera that resulted from that process. It's a 5-inch format, meaning 5-inch tall, rotating panoramic camera. So it rotates and moves the film through the camera as it rotates. And in so doing produces a negative that's about 23.5 inches long.
Is that an example behind you there?
Yeah, that's from that camera.
Is that a contact print?
I'm sorry?
Is it a contact print? Or how did...
That's bigger than contact, just a little bit, yeah. This actually, this was built for a friend of mine who, his main project for the camera was climbing to the top of and photographing from the top of every Rocky Mountain range peak over 10,000 feet. And another project that came along subsequent to that was this one, which was a, I don't remember the details, but it was a sort of a call to photographers nationwide to do photography related to food production. And so this is a cranberry bog that he's in, and he's actually in the boat making the photograph. And strangely enough, he doesn't like the boat in the photograph, but as far as I'm concerned, that's like the key element in the shot, that boat. So anyway, this actually, I think along the bottom here, or maybe I've trimmed it off, this is actually a calendar he produces. His standard size print is like 3 feet by 18 feet or something like that, really huge. Which involves anybody who does any kind of print matting, whatever that sort of stuff. Custom Lexan to get to that length, custom mat board to get to that length. He's got a 4 by 8 foot sealed dry mat press in his studio that he does the dry mat work with. His whole thing is kind of like, how difficult can you make it? That's the aesthetic, just how difficult can you make it? So anyway, more shots of that camera showing some of the details of how it's constructed. Let's see what we got here. Then a little bit about some of the inner workings of it. There's a thing that goes around the film at the back of the camera. I think it may be more clear further on, called a film wrap that holds the camera in a 180-degree circle as it passes across the slit that the image is coming through. Then this sequence here shows the reel load And then we're back to, at the bottom there, you see the bottom of the inside of the camera where the film is going across a driving spindle, and that film wrap actually wraps the film into a 180-degree circle, or semicircle, which provides the sufficient contact for that. It's hard to tell, but you can see a series of, it's a particular kind of polymer, but it's an O-ring made out of a particular material that you can see sort of behind it at the bottom. There's 3 little O-rings, and actually the drive surface that drives the film through the camera. And then the take-up reel where the film goes to has a slipping mechanism that drives it, but slips because the film is actually building in diameter, so it's not a constant velocity as the camera moves. Here another shot of the side of the camera, and then some really crappy videos I did with my point-and-shoot camera at the time when I was doing this, but they kind of get the point across. So you see a little bit of the, in the bottom one there, a standard run of the camera, and then a few things at the top, like they're showing the viewing window that's magnetically attached at the back of the camera. And then this is the rise-fall knob. The lens on the camera goes up and down, because since it's a full rotation camera, you can't point it down. But since what he was doing is put everything down from the top of the peaks, you had to lower the lens within the camera to get that view down below instead of just like all sky and a little bit of land. And then again up at the top, it's a little bit with the, I think we're looking at the user interface, and then finally running the camera again. And then there's a slit in the back of the camera that's got 4 different widths, and here I'm showing the changing of that. So what happened eventually with this camera is we decided to change it from that on-camera user interface to a remote handheld Bluetooth device with a touch screen. So that sequence there shows some of the original stuff, and then the transitions, like the top right is like removing all those buttons and things that are on top of the camera, and then replacing the one that was controlling the slit with the servo drive you see at the bottom. And that, of course, entailed this project here, which was breadboarding and then subsequently constructing the 2 halves. There's a couple of Bluetooth devices at the top and bottom of that breadboard that are the camera and the handheld devices associated with the process. Then there's the redesign of the interface circuit board for the top of the camera and the schematic associated with that. And then on the right, it's so small you can barely see it, it's just what the IDE looked like when I was designing the software for that. So it's like 3 or 4, I forget, maybe 3 different programs running there that were involved in designing in particular the interface on the Bluetooth device, which will come up here in a moment. So there's the body having been refinished. All the evidence of that prior user interface has been removed, and it's ready to get back to work. So here's on the right you see the camera, and then the handheld Bluetooth controller camera as it's being refinished. And then on the left you see the screen from the Bluetooth controller. And here I'm showing a sequence of how it actually operates. So you see that each time the dots are changing from touching that particular spot, you see a couple of transitions with the buttons on the right and left, showing a change of that particular element, and then subsequently exposure, and then this bar graph shows you the progress of the exposure. It's usually a lot slower than that. That would be a really rapid exposure for that camera. Typically it's 15, 30 seconds for a rotation, but can be a lot more if it's a long exposure. So then, actually going back a little ways, I worked with a woman on another project which was a linear panoramic camera. And actually, I'm going to pass this around because this is the only thing I could dig up. This is an example of some of the experiments we were doing with that camera. Essentially, it's like a typical, what's called a slit scan panoramic camera. We've got the film moving past the slit. And in this case, instead of the camera rotating, the camera is running on a track in a straight line. And the strange thing about that is that you get all kinds of interesting effects associated with it. And one of them is that you can only pick one subject distance at which things will be represented normally. Anything behind that, they'll get laterally compressed. Anything in front of that, they get laterally expanded. So it can make for some pretty interesting effects. And you know, this was the camera that we built. The one subsequent to that was built by another engineering firm looked more like an iPod compared to this thing. So now we get to the current camera, which is the one on the left up there. That particular one is a sort of a custom special edition version of it with the fancy veneer on the front. But this one came about in part because a lot of the people that own the other cameras were, I wouldn't say badgering me, but were interested in having a camera that shot a narrower field of view. 120 degrees is fun, but it's, you know, for composing sometimes it's kind of a trick if you've got something where you don't want to have that wide field. And so a lot of people were asking for a 6:9 format camera, you know, centimeter format. And in this case, 90mm field of view. It just worked out nicely that that's why it's called a P9, because it's a 90mm field of view and it's a 6:9 camera. So this one was designed in part as a response to these guys, which, as I mentioned, were a real bear to design and build, and so I wanted to simplify them quite a bit. So in this case, the front and back of the camera are built that way, but through fairly simple procedures. And then the top and bottom of the camera are built just out of quarter-sawn solid cherry. So then here's the inside of the same camera. Pretty simple. At this point, I'm using phenolic materials to construct the film compartment. And then there's an image showing the removable back, which slides down off the back of the camera. I can show you with that one later on what that looks like. And then just in the back center of the top of the camera, you see the latch knob. It's used for actually locking the back onto the camera when you've got it in place. So it's a much simpler design, and actually, as far as I'm concerned, my most successful for that kind of camera. I really like it. Plus, another thing about it is, you know, I should have dug it out. The front of that camera, the camera itself is completely inspired from a sketch that I had done in one of my sketchbooks that showed a camera that was essentially a rectangular view of the front of the camera, almost like a canvas view, so that I could have something to play with at the front of the camera, with everything sort of attached to the back of that. And that's pretty much what I ended up with. So it was pretty interesting to see it evolve from just a simple little sketch, because that's not normally what happens. Normally I go straight to a computer to design this stuff. So that made it a little bit more interesting. Here we got the side view. It's a pretty narrow camera, but the interesting thing, it's bigger than the other ones. It's a smaller format, and yet it's a bigger camera, but that's probably a result of trying to simplify it. Getting these cameras as small as they are was one of the many factors that made them as challenging as they are to actually construct. So this is quite a bit easier to build, and I think still a fairly compact size. It's got, on the right you see the film compartment with the springs like that on both sides, plus there's a plunger at the bottom that drops down to load the film in, which applies additional pressure to the film reels for maintaining the pressure on the film plane. Then here's just a shot of the front of that camera. I think earlier on I probably wrote in there that most of these productions of all these cameras, in fact this actually is an example of that. These cameras were normally made of cherry and walnut and actually I can't think, one other domestic hardwood. And at the end of each run, which typically is 12 cameras, I typically take one and do it in some fashion differently from the rest of them, that kind of a special edition. That particular one is made out of Cuban mahogany, which is my favorite wood, bar none, for just about any purpose. And it's an interesting story that came from some people that actually left Cuba in the midst of the revolution. And they had been there working with local craftsmen building furniture for them for years, so they had a big stack of Cuban mahogany that they took with them when they stayed to Miami. They subsequently moved to Houston, where they lived out their years until the husband died, and the woman put the house up for sale. A friend of mine bought it to do a typical Houston thing in those days, which is tear everything down except for the walls around the bathroom and call it a remodel and build a new house. And in the garage was this stack of air-dried 40-year-old Cuban mahogany. And he knew what I was doing. He called me up and said, I bet you would probably be interested in what I've got sitting here in the garage. And I went and took a look at it and essentially got to cull through it and pull all the quarter-sawn material out and stack it and then used it for all kinds of things until I think that was the last piece of it that went into that camera right there. So this is just another example of that. This is the standard camera, which normally is made entirely of cherry with cherry on the front. That's then, in this case, veneered with that crazy Italian veneer that I got from another friend of mine who used to work with a studio that also worked with the Torre Sottsis in Italy. That the Italians had, particularly in these days when he got this material, it's back when the Memphis movement was in full swing. And there were even shops in, I think in Milan, that would make custom laminates in short runs, which, as far as I know these days, is pretty much unheard of. You know, if you want a custom laminate, you're talking large-scale runs. But they were making, I think, as few as 25 pieces of custom laminates. And then these veneers were another sort of product of that. With a lot of these, they're dyed-through veneers, so if you were to sand through it, it's the same all the way through. Of course, the shape of each individual piece will change a little bit in that process. But a whole range of crazy veneers that I had from the guy who had done some furniture prototypes for someone at the time. Then some example images from those cameras. You can see the narrower format, the 6x9 format. That's, I think, up in the Newburgh area, a pond up there. That also in Newburgh. And then this was from a trip I took with my wife to Costa Rica. This great cathedral in a small town there that was built and never occupied because the earthquakes kept knocking it down before they could get it finished. So now we're off to another topic, which is a brief survey of some lighting stuff that I've done. This one here, as I sort of tried to point out in that introduction, is in part a result of two people that I'm real fond of in terms of lighting design, who are Ingo Maurer and Philippe Stark. And this one sort of reminds me of both of them, because Ingo, of course, is into the really lyrical, sort of very light, ephemeral almost kind of designs, and then Philippe is into the real polished, slick, overproduced kind of stuff. So this one to me was kind of a way of combining the two, and also another inspiration of mine, which is Japanese lacquerware and all the traditional stuff the Japanese made, particularly during the era when the samurai were rampaging across the country. There was some really extraordinarily beautiful stuff done with what is an utterly different material than what I got to work with there. That's nitrocellulose lacquer, and of course the lacquer the Japanese use is a completely different material. Here's a closer view of the base. This actually was designed, I've never actually followed through on this on the design, but it was designed to have a motorized system in the base of it that would do that motion that you saw, so that when it's off, it's in the upright position. When it's turned on, it actually folds down to the lower position and turns the light on at the same time. Another view here of the top, which to me was a shape that was sort of inspired by samurai gear, but I've had people comment in all sorts of ways. I think Darth Vader comes up quite often. Nuns have it, I think, was one that came up. So, whenever you design something, you never know how other people are going to perceive it. And a little bit about the process for that. This is a wooden plug, which was the starting point for making the base for that. And actually, I've got some of that stuff up here that goes on here to the silicone mold that's taken from the plug. Actually, there's a bit in between these two, but anyway, this is the silicone mold that's made from the final plug. It's a few stages beyond the piece I showed in the beginning. Then an interior view of that, which shows some of the inserts that are involved in either maintaining holes in it or providing a space for something else to pass through. And then there is an example of the interior of that after it comes out of the mold. And that eventually becomes that shape that's the base of that particular luminaire. And then I think here I've got, just a brief bit of a few others. This is one that I did. Another one where it strikes me that I had an idea, and I kind of went into the shop and over the course of about 2 days just kind of pull this thing together. And one of the goals was to have something where the power was being delivered up through the structure of the system. So it's a low voltage halogen light where the two posts that you see there are actually delivering the voltage into the system. And then you can pull it off of that cradle and actually bend it and adjust it for various angles and put it back down on the cradle. I won't try to go into where that name comes from. It was kind of a little family joke, and then along the side it's the same name in various languages. But it was kind of a fun little piece, and it's just kind of an incidental light. It uses regular incandescent light and a cute little switch off to the side that people really liked, I think, more even than the luminaire itself. And I've got another example of one like this. On another occasion, I went into the shop and had an idea that I just wanted to do something completely different, and not this one, but the one I actually have with me. I knocked out in a day, just like, I want to do something completely different from all this other stuff I was doing. And it turned into a short series that someday I'd like to continue. But anyway, the trouble with this is, of course, to do anything with it, I'd have to be going to the sci-fi conventions. And it's not a place I normally inhabit. And here a little bit on some machines. Over the years, it seems like I've been building machines quite a bit, either for my own use or for other people. I was doing a lot of that when I was working for Bill Collins for the Guitar World, building machines for building guitars. And then this is some examples, some of the stuff that I've built for my own use in the shop. If anybody's done mold work with silicones or casting, you know about getting bubbles into the material when you're mixing it up. This is a machine that I designed that's essentially a vacuum chamber for dealing with degassing materials for mold making. Again, anybody who's done much in the way of jewelry knows about non-conforming die press work. I think it's a really interesting process that's a lot of fun, and this is based almost exactly, except for the pneumatic actuation, on a design that's on the market that you can buy from a company called, I think the so-called Bonnie Bean, although a friend of mine bought them a number of years ago. I think he retained the name, but it's a really interesting process. Actually, I'm sorry I didn't bring something that results from that, because it's a really amazing thing. This rotational casting machine essentially is a mechanized version of the process you go through for doing slip casting with ceramics. So you're just trying to get a random action on a mold that's got a fluid inside of it that's going to make a shell on the inside. Though in this case, I'm using materials, various plastic resins, occasionally a little bit of plastic Paris. I did some concrete experiments. But in any case, what you end up with is a hollow shell because you've essentially rotated the material around the inside of it in a fairly random fashion. This guy's pretty simple, and basically his role is just got like interchangeable spindles on either side. It's essentially for sanding the insides of these curved surfaces that I seem to generate a lot of. And then there's like some discs and other things you can put on there, but it's basically just a spindle, multi-purpose spindle. And in this guy, when you're making lots of little hardware pieces like the knobs and such, you've got a lot of polishing to do, and because you're using abrasives, it's a good idea to not do that on the lathe. So in this case, I've made what amounts to a simple polishing lathe based upon a very expensive Albrecht chuck that I got for 20 bucks at a usual auction one time. I think that chuck it's like a 5/8 chuck. I think it's like 450 bucks. Bought one new. And then this is a curious little project that came my way from being in the building that I'm in over up at 28. I figured I'd try this. This is a scroll. I was essentially hired to do a proposal to do this job. So I spent 2 months getting into it because I didn't know anything about this topic. And so I had to do a bit of research even before I started even thinking about it. But once I did, I ended up generating some ideas and produced this scroll as my presentation for the meeting with the client to get the job, which I did. So what I've got here is I had it set up so you can scroll through it. This thing was like 5.5 feet long, and I rolled it up and tied it up so you could roll it out and read it like a scroll. And basically what it explains is this notion of winding mechanical watches, or automatic watches, what they're really called. A Rolex would be an example, but as it turns out, a Rolex is at the bottom end of the scale monetarily with respect to this kind of watches. Strangely enough, it's like when you buy a new car and you start seeing it everywhere. You've never seen it before, and then you buy it, and then all of a sudden they're everywhere. I mean, I was vaguely aware of fancy watches, and I have a really good friend who's a clock builder who builds these really extraordinary clocks based upon 17th century regulators. So I was aware of them, but when this project came along, I started seeing these crazy watches everywhere. Like New York Times, New York Magazine, Smithsonian. Everywhere you look, there's some full-page ad for some automatic watch. And when I started looking into it, I was astonished, because I'd say the average cost of these watches is $75,000 to $100,000. And way up from there, depending upon what kind of things you want to do with it. So anyway, this is a young guy, made boatloads of money in the tech world, and managed to sell his company before the tech bust back in the day. And he's got his obligatory collection of watches. And so that's how the project came along. But we were doing this project right in the midst of the free fall in 2008. And he would, this is a person who. Actually, another person, the person I got this job through is a furniture maker here in town. He does really extraordinary work, and he's made probably 50 pieces of furniture with this guy at this point. And that was my connection, because he kept sort of upping the ante. He wanted to do things that were more and more sort of mechanical and did things. And Greg was just not really into that so much. And when he came up with this idea, Greg made a couple of stabs at it. He took it to a friend of his who's got a medical engineering company here in town who does amazing work, but the guy told him, you can't afford us. Doesn't matter how wealthy this guy is for this project, you can't afford us. So he started asking around, and it was a neighbor in my hall that actually sent him my way at that point. And so we started into the project, but as the economy started getting worse and worse, he'd come to our meetings and have his iPhone with him, and he would be sort of, I guess, looking at financial stats, watching his huge fortune turn into a slightly smaller huge fortune, but nonetheless enough to spook him out of, I suppose this is what happened, continue on this project. So it got into the prototype phase. It did a lot in fact, I've got some examples here of the sort of mock-ups that I did to get it going. And then I did a lot of the software and hardware design and prototyping for it, and even some testing for some of the various aspects to the design. This is essentially what the mechanical system looks like. It would be enclosed in something. I originally had an idea of my own about how that would be done, but because Greg, the furniture maker, his personal furniture maker, was involved, it eventually became a project where I was going to do essentially this part, and then we're going to address each one in a separate case made by Greg, each with some different form. And so then we've got, let's see, what is this? This would be back view of the mechanism, and then this would be the front view of the mechanism. And I suppose I should, I think there was one at the top of that scroll, but the thing about these watches is that because they're so expensive, and because the people that build them, most of them are in Switzerland, but a lot of them are in Germany and Italy, and even here, a few of them, and a really interesting new one in Ireland, of all places. Because at this level anyway, the watches are so incredibly expensive and intricate and involving really elaborate materials and crazy processes. Everything's done through some kind of viewing device because it's too small for it to work on otherwise. Because of that, they're real proud of what they do, and they like to show it off. So very often these watches have some kind of element of transparency whereby you can see the mechanism inside of the watch. And once I really started, and as the client started bringing me these huge glossy magazines that were like trade magazines for the watchmaking world, and I started looking at all these things where there's like this mechanical circus going on inside of a watch. And so after going through all these various options for possibilities for design for this watch winder, this is what came out of it, because what I wanted was something that was essentially a mechanical circus, whose purpose is to rotate 12 watches on what amounts to a Ferris wheel, to move each one to a location at the top of the system, whereby then this mechanism moves and transfers the rotational activity from moving the Ferris wheel part of it to rotating the watch itself.
What's your power source? In
this case, it's a simple little motor that's, let's see, I have a pointer, and the motor's not really shown there, but it's a motor that mounts right in the middle of the front of the system. It's about yay big and about that thick.
And it's
oh no, the whole thing would be run off of mains power.
Okay.
It's a very fancy Swiss electronically commutated motor.
And then is there a rotary connection between them?
Yeah, that's what all the gearing's all about.
Okay.
So it's driving the whole system through all the gearing inside of the system. So there's the big ring essentially is operating. You can see a wheel at the top left and the top right that the wheel is operating on, and then there's one at the bottom that's actually the driving wheel. That's what spins the ring itself. But then there's a series of gears between those parts of the mechanism and the motor itself.
So each time they're connecting, you're going to get another power source, or is it each has its own power source?
Yeah, there's two separate power sources, one to drive each one, but there's one that's actually moving the mechanism up and down, and then one that's driving the rotational activity. Any other questions about that? It was an interesting project, but it is, as far as I know, permanently on hold right now. A little bit of the sort of drawing, design work for it, and then some of the drawings that went into doing it. Because in this case, I was probably just going to job out all of it, so I had to do much better drawings than I'm accustomed to doing. Generally, I do enough drawing, I can get in the shop and figure the part out. But in this case, I've got to have these really nice, like finished quality parts, not just mechanical parts, but really high level of finish. So I actually was lectured by one of the guys that I took the drawings to as to how I needed to improve them, and this is what resulted. And that's pretty much the end of the bulk of what I'm showing here. I'm putting this up because next week is Worldwide Pinhole Photography Day.
Yay.
It's a day on which people all over the planet will go out during the course of that day and make pinhole photographs.
Cool.
And then they all submit to a website where, I don't know, I forget what the numbers are, there's pretty huge numbers now, that all their work gets displayed on the website through the rest of the year. I think over the course of the next 2 months, they'll be accepting submissions. And it's amazing stuff, absolutely amazing stuff that people do. And so that's the end of that part. We'll pass that around, which is another image from one of these, actually from that camera. And let's see, what else have we got here? Anybody who's interested in this mumbo jumbo, that is fourth code. It would take a geeky programmer to be interested in that. And then, I don't know what to do with this. It's something, we have a contest or some sort. Maybe you guys can figure something out. But I've got essentially a fold-up pinhole camera that can be assembled around a little bit of extra cardboard. And it's available to give away. So maybe we can come up with some means of selecting out from the group as to, yeah, even the printing is from when it was done. Yeah, it's also probably a dot matrix printer.
What was that thing that you were talking about?
It's a pinhole camera. I'm sorry, I probably didn't explain it fully. Yeah, it's this photo agency that does stock photography in New York came up with that, and they commissioned a variety of different people to come up with different designs for them. And they're really cool when you fold them up, and they use 35mm film. You can actually download the stuff off their website and print them out and do them yourself.
Nice.
But they're really cool. They're pretty neat.
Do you remember the agent or the?
It's on there, I believe. Do you see the name? Maybe the bottom right, the bottom left.
Corbett?
Corbett. Is that? Let me see.
Corbett?
Corbett. Yeah, Corbis.
Yeah.
Corbis.com. And these are called, I think they're called ready-mades. So if you go to Corbis.com and look for ready-mades, you'd find those. They're a lot of fun. I think I passed this around. This is just an example of this. That was one of the circuit board designs for the top of that rotating panoramic camera. This is an example of one of those base castings for the Luminaire. This guy here is a prototype. I think it's going to probably stay together. I don't know if I have it all pinned. As long as you handle it gingerly. This is a watch holder from the watch winder. So it's designed to expand into the watch. The watches, of course, are very expensive, so you don't want to scratch them. So you have to figure out a way to hold the watch so that it can be held in this watch winder, so you'll see the front of the watch and not much else, but protect the watch. So the back of the watch is here in the open space, so it won't get scratched. And this is just contacting the band of the watch. That's that one around. This is lacquer. That's lacquer, and that's unfinished. That's just the sprayed on. It would get hand rubbed to like a piano sort of a finish when it's done. This is a wooden pattern that was used to generate the molds for the panoramic camera. And that thing's probably not handleable. This was the original. This is, I never did retrofit this with the ultimate design I have for the battery system, so it's essentially non-functional at this point, but this was the original torch design. Now, I mean, I don't know what. Yeah, it's a ritual object is about all I can say. Whatever your ritual is.
So then does the battery go back here?
Yeah, I'll pull it apart and show you so people won't have to do it. That's the switch, the part you're actually working with there.
Cool.
And then if you pull the whole thing apart, the guts are basically out of it right now.
Right on.
But that would be the battery load like that.
Mm-hmm. That's really neat. I like it. And then you just pointed at what you want to light up.
Yeah.
You're like, and illuminates.
Yeah, basically an LED. LED right at the bottom. It's kind of that. And this guy sitting up here, you can come and look at. It's probably a little awkward to try to pass something like that around. It's a 5x7 camera that I built probably in 1992. the kind of stuff that I was doing those days, these large format cameras that are very, very popular among the large format crowd. And 5x7 was my favorite format, my favorite size, but the film is going to be fairly challenging to come up with. And in this case, it's got a pinhole lens board on it, but it has a multi-position turret. So actually, I don't have it open. It's a pneumatic shutter. Well, anyway, there's a. See what I'll do. I'll pass that around. So that's probably easier to handle. Bellows design is interesting. It's something I had to research early on. It's how you design and build bellows. It's kind of a tricky process, but it's fun to get them all folded up and play with them once they're all done.
You make your own bellows?
Yeah.
It's a terrible addiction.
How? I just wrote this
I have, let's see, this is actually one of my working cameras. And then I have one like that I use quite a bit, and that's another one of my working cameras. So it just depends on when I've got time. Right now I'm buried under a remodel on my own house, so that pretty much takes precedence. My wife is living with me in a trailer in the driveway. So needless to say, the pressure is on. So not a whole lot, but I like to get these two and my version of that out whenever I can and shoot with them. A lot of fun.
I didn't usually get like
I guess if anybody's interested in that, there's that silicone mold.
Yes. On the pinhole cameras, what's the like basic exposure like for like daytime, like for some of the shots?
Well, almost all of the ones like this that I make are f200, so it's 1 second plus.
That's it.
Yeah, 3, 1, 2, 3, somewhere in
So
there.
it's like a 2.5 frames, like the ones.
This one uses a standard frame sequence, so it's 1, 2, 3, 4, 5. This one uses 2 of a normal frame sequence, so you just go 1, 3, 5, 7, 9.
So when you wind it, you know where you are though? Like
Yeah, they all have, let's see here. They all have the red window on the back.
Oh, so it's on count with like 120 film.
It's 120 film, not 220
Yeah, but I
obviously.
mean, you're not on your own, like, just
No.
like, do it 5 times. and-
No, no, you either have to have obviously a mechanical counter, accounting for the film build, or you've got to have something like this, or allow for, variation in spacing through the roll, which some people will do. But in this case, I just rely on the traditional numbering system on the paperback,
Makes sense, yeah.
and it works just fine.
How does the film stay round to the back right there? Is it going through a channel or?
It's not required. For a flat film plane, you need some kind of a pressure plate or a channel. But on a curved film plane, you have, for lack of a better phrase, I'll use monocoque. It's like it's a structure whereby if you've got tension on both ends, it can't be anything but in that curve held against those rails. Does that make sense?
Yeah, well, I guess it's the rails I'm having.
Okay. It's very simple. In this case, it's extremely simple. It's just a wooden face on the film compartment. So it just wraps around.
The back of the
Right.
wood.
Yeah.
Yeah, okay. Yeah.
It doesn't even require top and bottom guides because it really can't go there. Now this is a pinhole camera, and pinholes will cover quite a bit. I think you could probably squeeze 160 degrees out of one, but you do get a bit of fall off at that point.
So on the far back, that's your rotation.
Yeah, I mean, this was for a 35 millimeter setup, so that's a rotational camera, and it's also sort of missing guts because that was just kind of a sketch we're playing with. But it would be driven by a motor that would reside on this side and drive 35 millimeter film through the camera. It's a split scan camera.
Only have maybe one piece of film. You're only going to expose it once.
No,
You might.
I don't know, what would that be? You'd probably get like 4 exposures out of a 36. I'm guessing. I can't run the numbers in my head that easily, but.
Oh, it's 35.
Yeah. Yeah, and then as they go further down the line with the film rail system, they get a bit more elaborate. I'm sorry. What was his name? James. James. Here's a future example further down the line, and this is what I was talking about, where the film has to slip underneath.
Yeah, that was what kind of started my thought. Like, how does that stuff fit in there anyway? So as the channel is in front of it, then. Yeah, that's what I was wondering. That space right there. Oh, that's beautiful. This light.
And you know, that's one of the many things, complicated things about that camera. You see, in this case, we've got a latch knob on the back, and then the back just slides off. And then we're back to a much simpler system for guiding the film through the camera. No feeding it through underneath anything. It's back to pretty much a wooden surface, which is really all you need. As long as it's held, that's what the springs on either side, their purpose is, along with the plungers on the bottom, all of that provides a certain amount of tension on the film, so that as you wind it, you're essentially stretching it across that film plane. And that's what keeps it there. So you really don't need any kind of other pressure plates. Any other questions? Or you're welcome to come up and look at these larger items here.
I saw it was not stereophonic, but it was stereoscopic, maybe? What is that? I have no concept of what it is.
Oh, okay. Well, stereoscopic photography is just basically operating on the premise that, you know, the way you normally see things, you've got 2 lenses, you're looking at 2 views, and you get parallax, which is how you perceive depth.
Right.
So if you make a photograph that recreates that environment, where you've got 2 images taken with that same parallax difference, then you will recreate that sort of 3D environment.
So it kind of gives a 3D
It gives a very strong 3D effect,
okay,
yeah.
right.
Particularly if it's done well.
Okay, so that's kind of how they make like cameras that shoot 3D.
3D cameras. For the most part, there's some other ways of doing it that are a little trickier, but typically it's 2 lenses, one side by side.
Oh, cool. Okay.
Yeah, it's pretty straightforward.
Yeah, I've
And
heard
then-
the term and I've just been like, whoa.
Yeah, I mean, and in that case, it's this same format, and the lenses are in there at pretty much what's called the interocular distance of humans.
Okay.
The average range of human eye interocular distance. So the images from this camera are readily viewable in a way that makes sense to you, regardless of what the subject distance is. But if you, for example, were going to shoot a stereo photograph of a distant range and there's virtually nothing in the foreground, you can take a single camera and set it up in one spot, and then move it several hundred feet that way, and photograph the same scene from that spot, and then by carefully aligning them for viewing, get an image that represents that mountain range with the kind of depth that you would perceive at a much closer distance normally. And then conversely, if you were looking at one of these watches that I was talking about, and the same thing, one lens, and you took one image and then shifted it maybe a millimeter, you know, because you're at such close scale. You get the same thing in that case. You get this really deeply stereoscopic effect on a very small one.
Oh, that's cool.
Yeah.
Have you seen the 3D museum in Portland?
Oh yeah. Yeah, fun stuff. Yeah, no, there's actually a 3D digital camera, I forget who, Fuji I think makes right now. I hadn't actually seen one until a couple of weeks ago, and a guy had it with him in another museum I went to. And it has a screen, a viewing screen on the back that shows the images in 3D. Oh, it's really cool.
That is awesome.
Yeah, it's really neat. In fact, he said the biggest problem with the camera is you can't find a better way to present the images than what the camera does in the back of the camera. Because you have all these different ways you've got to use to view a 3D image. You know, you've got a viewer of some sort, or if they're big print, you've got a splitter, a mirror splitter, or all kinds of different techniques. And it always requires some kind of adjustment in your head to make it pop and make it actually work. And if it's not done right, it just gives you a headache.
Yeah.
It doesn't work at all. Yeah.
Oh
yeah, especially with the movies. It's really bad because that's a long exposure.
Actually, I've seen a lot of them recently.
Anybody else? And I shoot digital. I get digital cameras, but primarily for documentation purposes. There's a way of doing rotating panoramic cameras with digital, pretty obvious. But there's also a couple or maybe 3 at this point companies doing it very well. So, and there's not a huge market for that, nor for any of this, but certainly not for the kind of expenditure involved in developing that kind of technology into a product.
Handmade digital.
Yeah. Doesn't make a whole lot of sense.
Got a question on the 360, because he must have shut that on the boat, right?
Yeah.
So
Now, how he got it to not move,
yeah, that's because he's on that's on a
I don't know.
tripod just going around and.
well, that's probably.
So how'd he get out of the way?
That's probably. Well, that's another good question.
Is that why you cropped it down? Like, didn't you say it was on a holiday?
No, the only reason it's taller is because down at the bottom there's a calendar. There's months written across the bottom is a calendar.
What film was that shot on?
It's custom 5-inch film, and he has a custom order number from Kodak for $5,000 minimum order.
Wow.
The pinhole panoramics, I've shot with wide locks, and I know that when you shoot into a light source of any sort, you get those really odd dumbbell lens flares.
That's from the swing lens itself.
Oh, okay.
That's a streaking that comes from that lens swinging in the slit. Actually, it's got light bouncing inside of that. Even after you pass the spot where the light is, there's still light bouncing around in there, and so it's just scanning that right across the film.
Even despite the felt on the inside,
it's really hard to get rid of that. It can be done, but that's just a feature of any kind of rotational panoramic camera, whether it's a swing lens or rotator.
Did you make a swing lens? I mean, there was.
Yeah, there was one on there. Yeah.
Okay.
Yeah, and that's the first time I noticed that with any intent, really, was when I first built that camera and started shooting. You get light sources in there and you get this streak across the image. So the pinhole cameras don't do that. I mean, they'll get more like a blowout or some other feature that's a result of big light source in the image, but they won't get that streaking because they're not scanning like that. Right.
All right.
Anybody else?
Well, let's give a hand to Kurt. So if you guys want to come and check out the cameras closer, ask Kurt any questions, please feel free to do so. I just wanted to tell you guys the next meeting commences Tuesday, May 3rd at 6 p.m. And we have Joe Mansfield and Ken Tomita of Grove. Founded in 2009, Grove is a team of designers and makers in Portland, Oregon, focused on changing the way you think about products. By doing everything themselves and only selling direct to the consumer, the result is greater innovation, complete accountability, direct human relationships, and superior quality. Grove curates an artist series of laser-engraved bamboo iPhone 4 cases, iPad 2 leather and bamboo cases, iPad 2 bamboo skins, and bamboo wall art featuring the work of prominent illustrators from around the world. Grove is more than a company, but a community of passionate creators. All right. It's going to be great. Thanks, everybody.
12,000 which is optimum for this distance, that focal length. Right.
What price point are your cameras, like the P90?
These typically are in the $1,000 range. The P90 is $1,000 with a bubble level like that one has on it.